Welcome to electronic section here, and you are watching the digital signal processing previous year question series. And in this lecture, we'll see the 6 mark questions of the question series, that is 23-24. So we'll see 4 number of 6 mark questions. Okay. So first one is here, explain the signal, given signal, that is as the time shifted impulse. Okay, time shifted impulse means impulse signal is time shifted. It is del of n minus k. Okay, so let us see that. So what is the formula for finding out the x of n can be expressed as a sum as the time shifted sequence is the formula. Okay, for x of k, del of n minus k. Okay, so it will be del of n minus k, which will be 1 for n equal to k, and for n is not equal to k, it is 0. Okay, so now x of n, you can see x of n, it can be expressed as this term x of 0 into del of n. Similarly, x of 1 into del of this k value. I am talking about this k value. It is from, you can see, this is 0, 1, 2, 3, 4, 5, 6, and 7. So it's k equal to from 0 to 7. Okay, so it is from 0 to 7. Okay, so x of 0, then k equal to 0 means it will be del of n. Similarly, k equal to 1, which is del of n minus 1. Similarly, 2, 3, 4, 5, 6, and 7, up to 7. So x of 0, what is x of 0? X of 0 equal to 1. Similarly, x of 2 equal to 3. X of 2 equal to, 4. X of 1 equal to 3. X of 3 equal to minus 7. Likewise, x of 7 equal to 20. Just put the values of input values. So you can see this is the answer. Okay. So x of 0 equal to 1, so it will del of n. X of 1 equal to 3, so 3 of del of n minus 1. Then 4 of del of n minus 2. X of 3 equal to minus 7, so that will be minus 7. Then 8, that is minus 15. Then x of 6 equal to 18. Then 20. Okay. So this is how we have expressed the x of n in terms of the time shifted impulse. Time shifted impulse means these are the time shifted impulse. Del of n minus 1, del of n minus 2, these are the shifted impulse. Okay. So this is a 6 mark question. Okay. The second question will take differentiate between odd and even signal with suitable example and neat diagram. Okay. So odd signal and even signal. A discrete time signal is said to be anti-symmetric or odd signal if x of minus n equal to minus of x of n. Okay. For all n. Similarly, a discrete time signal x of n is said to be symmetric signal or even signal if it satisfies the condition x of minus n equal to x of n. Okay. So if this satisfies, it is the even signal. Okay. For odd signal, x of minus n equal to minus x of n. Okay. So this for odd signal, if the signal is comprised of two parts, okay, one is your even part and odd part, then it will be x0 n. This is the x of n actually comprised of two parts, x of 0 n, that is the odd part, then x of e, that is the even part. So this odd part can be expressed in terms of the means x of n as this one. Okay, so half into x of n minus of x of minus n. Similarly, the even part can be expressed as this half of x of n plus x of minus n. Okay. This is the suitable diagram. Okay, so this is the x odd signal. In this case, this is the condition: x of minus n equal to minus of x of n. Similarly, x of minus n equal to x of n. This is the where the x of minus n equal to minus n means you can see x of minus, what is x of minus n? You can x of minus 1 suppose. So x of minus equal to x of 1. Okay. So this sample amplitude and this sample amplitude both are same, you can see. Similarly, x of minus 2, this is x of minus 2, this is x of 2. So the amplitude are same, you can see. Similarly, minus 3 is same and minus 3, and so on and so forth. Okay. So this is the examples of a even and odd signals. Okay. So let me. Uh, uh, the odd signal is symmetric and it's called the anti-symmetric signal. Okay, the odd signal is the anti-symmetric signal. That is the is anti-symmetric about the origin. This is the symmetrical signal. Okay, about the vertical axis. The odd signal must necessarily be 0 at the time origin equal to 0 to hold x of 0 equal to minus x of 0. So at time origin, the odd signal amplitude is 0. Similarly, the even signal is reflection of the about the origin. Okay. So this is the area under the odd signal is always 0. Similarly, area under the even signal is twice of that the one side area. Okay. So these are the means differentiate between odd signal and even signal. Similarly, check the whether the given systems are linear, time variant, causal or stable. You have to check the system. Okay. So this is a question: y of n equal to x of n plus n into x of n plus 1. Okay. So linearity check first. If the signals are input signals are x1 of n and x2 of n, the corresponding outputs are, this is the transformation of x1 of n. You can in place of x of n, you can replace x1 of n. So it will be x1 of n into x1 of n plus 1. Similarly, x2 of n plus n into x2 of n plus 1. Okay. So this is the linear combinations of the x1 of x2. So it will be y3 of n equal to transformation of a1 x1 of n plus a2 x2 of n. So in place of x of n, you can replace a1 x1 plus a2 x2 n. Okay. So this is the, you can, this equation, you can, in place of x of n, you can replace a1 x1 plus a2 x2. Similarly, this one also. So it will be a1 x1 n plus 1. Similarly, it will be n plus 1. Okay. So just multiply this. This is our equation 1. Okay. Similarly, you can multiply here a1. This is the why the signal is called the linear if this a1 y1 of n plus a2 y2 of n. So which is equal to y3 of n. If this condition satisfied, the signal is linear. The system is linear. Okay. So now what is a1 y1 of n plus a2 and y2 of n? This one is this one. Okay. So in this case, y3 of n also we can see this term. Okay. So because of these two equation 1 and 2 are identical and this superposition theorem is satisfied, that is why the system is called the linear system. Okay. So let us try to see whether the system is shift invariant or not. Okay. Shift variant or time variant. Okay. So y of n is the question. So for shift variant check, you have to apply the input sequence is delay by k samples in time, then apply to the system. So first delay this by k samples, so you can get y of n comma k equal to transformation of x of n minus k. So it will be x of n, only delay the input samples, x of n minus k, it will be n of x of n minus k plus 1. Only you can see n is you can see that is the only you can delay the input only, not this n. Okay, only delay the input. Okay, by k samples. So you can get y of n comma k. Similarly, what is y of n minus k? 1 minus k, it is the replace. You can replace. Okay, replace the whole equation n with n minus k. In this case, you can replace n by n minus k. Okay, so this is the extra term you will get. This will be n minus k. So what is the actually our equation? Uh, you can see what is the equation: y of n equal to x of n plus n into x of n plus 1. Okay, so n plus 1. Okay, x of n plus 1. So you can see if we replace n by n minus k, this will be n minus k plus 1. Okay, similarly n into question is your x of n plus n into x of n plus 1. So you can see replace n with n minus k. So you can, all the n would be replaced by n minus k. So in this case, this both are not equal actually. So that is why it is shift variant. If both are equal, it will be invariant. Okay. So now the causality test. So in this case, the system is non-causal because you can see the output depend upon the future value of the input. That is why the system is called the non-causal. You can see this is the non-causal. Okay. Last thing is the due to stability test. Stability means for every bounded input, if the output produces is bounded, then it is called the stable system. Okay. So let us see that. So this is our questions. So we are applying bounded input as u of n is the bounded input. So let us apply that. So you can see it is y of n equal to u of n plus n into u of n plus 1. So in this case, if we put over here n is tends to infinity. Okay. So if n is here, actually you can go for n is infinity. If we take n equal to infinity, then y of n also actually infinity. Okay. So because this n is equal to infinity, this is actually bounded input signal u of n, but there is a n over here. So if we put n equal to infinity, so y of n goes to infinity. So that is why this is not stable system. So this system is not stable. Okay. So last one is your find x infinity. X of z is given by, there is x of z is given. You have to find out what is your x infinity. Okay. So this is actually final value theorem. Okay. This is called the final value theorem. So you can see x of infinity equal to, this is the x of z is tends to infinity x of z. Okay. So in this case, you can see limit z tends to infinity, z square divided by, this is the question, z minus 1 into z minus 0.3. So in numerator and denominator, it just divide by z square. Okay, so you can get this. Okay, so here also we can divide z square. Okay, similarly here z square means this z divided by this would be z. Okay, so z minus 1 divided by z would be 1 minus 1 minus z. So it will be z minus 0.3 by z. So 1 minus 0.3 divided by z. So when here you can put z is tends to infinity. Okay, so z tends to infinity means 1 upon z equal to 0. Okay, so z is tends to infinity means 1 upon z is tends to 0. So it will put over 0. So it will be 1. Okay, so the x of infinity equal to 1. Okay, so this is our final value theorem. Okay, so we have seen 4 number of 6 marks questions. Okay, so the next lecture we will see remaining means 4 questions. Okay, so total actually 12 questions are there. Okay, so we'll see one by one. Okay, so for the set of 4 we'll see. Okay, so thank you for watching this video. These are our references. So if you have any doubt, you can free to ask me in the comment section. Okay, and thank you all. Have a nice day.